The optional calculations for high-rise condo services allow for a more customized and accurate estimation of the total demand on the common bus duct. The demand factor for a single meter center, serving 22 units in this case, is applied to account for the diversity of loads within that meter center. This means that not all 22 units will be drawing their maximum demand simultaneously. By taking an additional demand for the total number of meter centers, you are accounting for the fact that there may be some diversity between the different meter centers. In other words, some meter centers may be drawing at a higher demand than others. This additional demand provides a margin of safety to ensure that the bus duct is adequately sized to handle the total demand of all the units connected to it. When calculating the electrical load for a high-rise condo with multiple meter centers connected to a common bus duct, you can indeed apply an additional demand factor after initially applying the demand factor for a single meter center serving a specific number of units. This approach considers the diversity of electrical usage across different sections of the building, leading to a more accurate estimation of the overall load in the bus duct. The initial demand factor applied to a single meter center accounts for the fact that not all units within that section will be drawing maximum power simultaneously. This is based on the statistical probability of simultaneous usage and the types of loads present in those units. Once this initial demand factor is applied, an additional demand factor can be applied to the total number of meter centers connected to the bus duct. This secondary demand factor accounts for the diversity of usage between different meter centers. For example, one meter center may serve residential units with primarily evening peak loads, while another may serve commercial spaces with daytime peak loads. Therefore, not all meter centers will be drawing their maximum demand simultaneously. The specific values for these demand factors are typically based on historical data, engineering judgment, and relevant electrical codes and standards, such as the National Electrical Code, or NEC. These codes provide guidelines for determining appropriate demand factors based on the type of occupancy, the number of units served, and other relevant factors. By applying both demand factors, you can more accurately estimate the overall load in the bus duct, which is crucial for selecting the correct size of the bus duct and associated electrical equipment. Undersized equipment can lead to overheating, voltage drops, and potential safety hazards, while oversized equipment can be unnecessarily expensive. In summary, the two-step process of applying a demand factor for the individual meter center load and then an additional demand factor for the total number of meter centers is a valid approach for calculating the electrical load on a common bus duct at a high-rise condo. This method accounts for the diversity of usage both within individual sections and between different sections of the building, resulting in a more accurate and efficient electrical system design. The steps to take are: firstly, determine the load served by one meter center. Secondly, apply a demand factor to that meter center. Thirdly, determine an additional demand factor to apply to all meter centers. And fourthly, calculate the total load on the bus duct. The National Electrical Code, or NEC, provides guidance on how to perform the calculations. Consult the NEC for the addition that is in effect in the relevant location. Demand factors reduce the calculated load due to the improbability of all loads operating at the maximum simultaneously. The procedure to calculate the load is: firstly, calculate the total connected load. Secondly, apply demand factors to the connected load. And thirdly, determine the design load which is used to size equipment. It's important to consult with a qualified electrical engineer and adhere to all applicable electrical codes and standards when designing and installing electrical systems for high-rise condos. The NEC provides tables and guidelines for demand factors applicable to various types of occupancies and loads. These demand factors are based on statistical data and engineering judgment, aiming to reflect the actual load profiles observed in similar installations. The application of demand factors is not arbitrary but rather a calculated approach to optimize the electrical system design while ensuring safety and reliability. It is important to maintain detailed records of all calculations and assumptions made during the design process. This documentation is essential for future reference maintenance and potential modifications to the electrical system. The demand factors used should be clearly justified and supported by relevant data or code references. Moreover, Regular monitoring of the actual electrical loads in the building can provide valuable insights into the accuracy of the demand factor assumptions. If significant discrepancies are observed, adjustments may be necessary to ensure that the electrical system remains adequately sized. Consider the impact of future expansion or changes in occupancy when determining demand factors. It may be prudent to incorporate a safety margin to accommodate potential increases in electrical demand over time. Coordinate closely with the building owner, property manager, and other stakeholders to understand their expectations and requirements for the electrical system. Their input can be valuable in making informed decisions about demand factors and overall system design. Consider the use of energy-efficient appliances and equipment in the building. This can help reduce the overall electrical demand and potentially allow for the use of lower demand factors. Explore the possibility of incorporating renewable energy sources such as solar panels into the building's electrical system. This can reduce the reliance on the grid and potentially lower the calculated demand. A comprehensive electrical system design should consider all aspects of the building's electrical needs, from lighting and appliances to HVAC systems and elevators. A holistic approach ensures that the system is properly sized and optimized for the specific application. Demand factors are just one component of the overall electrical system design process. A thorough understanding of electrical engineering principles and applicable codes and standards is essential for creating a safe and reliable electrical system. The importance of consulting with a qualified electrical engineer and adhering to all applicable codes and standards cannot be overstated. A well-designed electrical system is essential for the safe and efficient operation of a high-rise condo building. The application of demand factors can significantly impact the sizing of electrical equipment and the overall cost of the installation. A careful and deliberate approach to determining demand factors is therefore crucial for ensuring a successful project. In the context of high-rise condo services, applying the optional calculations requires a comprehensive understanding of the electrical loads within each unit and the diversity of usage patterns among the units. The demand factor for a single meter center accounts for the fact that not all appliances and equipment within those 22 units will be operating at their maximum rated power simultaneously. This diversity is due to various factors, such as residents having different schedules, using different appliances at different times, and varying levels of energy consumption. After applying the demand factor for the 1 meter center, which reduces the calculated load based on the anticipated diversity within the group of units, you can then consider an additional demand factor for the total number of meter centers on the bus. This additional demand factor accounts for the diversity of usage patterns among the different meter centers. For example, some meter centers may serve units occupied by individuals who work primarily during the day, while others may serve units occupied by individuals who work primarily at night. As a result, the peak electrical demand of the different meter centers may occur at different times. By applying an additional demand factor for the total number of meter centers, you can further reduce the calculated load in the bus duct, taking into account the diversity of usage among these different groups of units. The specific values of the demand factors used should be based on sound engineering judgment, historical data, and any applicable codes or standards. It is important to carefully document the basis for the demand factors used in the calculations, as this information may be required for review by regulatory authorities or other stakeholders. The overall goal of applying demand factors is to accurately estimate the maximum electrical demand that the bus duct is likely to experience under normal operating conditions. This information is then used to select the appropriate size of the bus duct and other electrical equipment, ensuring that the system is capable of safely and reliably supplying the required power. An overestimation of the electrical demand can lead to the selection of unnecessarily large and expensive equipment, while an underestimation can lead to overloading, overheating, and potentially dangerous conditions. Therefore, it is important to carefully consider all relevant factors when determining the appropriate demand factors to use. Applying demand factors to calculate electrical loads in high-rise condos accounts for realistic usage patterns and prevents oversizing electrical equipment. It ensures cost efficiency and safe, reliable power distribution.